All right, take two. All right, we got two formulas that we really worked on in this section. So the first one was way up here. This was like our given formula. So probability of A given B equals probability of A and B over the probability of B. Very important on that one, the order does matter. And now on the second page, we got our second formula here, which was the probability of A or B equals probability of A plus probability minus probability of A and B. All right. So I went ahead and rewrote this one here. And so what we've been doing on these last few problems is kind of just plugging in what we know and leaving as a variable what we don't. All right. And so for this one, it says there's a 90% chance that Belinda will pass her math test. So let's go ahead and call the math test. Let's call that A, event A. It doesn't really matter which one you call A as long as you kind of know what it is. And so the probability of A then would be 0.9 because it's saying she has a 90% chance of passing her math test. All right, she has a 60% chance that she will study all night and pass the math test. So that is and so and goes here in the in the symbol that's kind of not a U, it's an upside down U over here. Remember the U symbol here means or, and then the upside down one means and, right? Okay, and then we have a 45% chance she will study all night or pass the test. So that is our or probability. So I'll put that up here at 0.45. All right, and we'll label this as a variable. All right, and so I would just combine like terms. So we have these two that equals 0.3 plus x equals 0.45. And we'll subtract the 0.3 over. So 0.15 equals x, and so that would be a 15% chance that she studies all night. All right. All right, so now we got this on a Venn diagram. So we have like the vanilla only, the chocolate only, the chocolate and vanilla in the middle, and then the neither on the outside. And so it says, what's the probability that a student likes either chocolate or vanilla? So we have probability of chocolate or vanilla. Now we could actually use the formula for this. So the probability that she likes chocolate, or let me actually write out the whole formula here. All right. So the probability that she likes chocolate is actually 0.5, and I got that by doing 0.2 plus 0.3, because 0.2 and 0.3 are both chocolate. All right, and then the vanilla would actually be 0.6 if I just did probability of vanilla on its own, because that's the 0.4 plus the 0.2. And then I would have to subtract out the 0.2 there, because I kind of counted that twice. You can see it was part of the 0.5 and the 0.6. And so that would give me 0.9. So 90%, okay? So that's one way to do that problem using the formula. The other way to do it, and you know, on tables and like charts like this, I would probably suggest the other method, which would be probability of A or B. You just kind of look at, you just add up all the pieces that would kind of count here. So just do 0.4 plus 0.2 plus 0.3. And so that would also give me 90%. So kind of two options for you when you have a table or a chart. You can kind of use your logic, or you can use the formula. But when it's like one of these word problems up here, you kind of have to use the formula. So that's why we're using that formula on those problems, whereas on this one, you can kind of go either way with it, all right? All right, and last thing we're going to talk about is called mutually exclusive events. All right, so it says sometimes when calculating an or probability, there is no overlap. All right, So we're going to look at some examples here when there would be no overlap, or said another way, the probability of A and B equals 0. So these are called mutually exclusive events. Another explanation is that the events cannot possibly happen together. Okay, when this happens, you can just skip subtracting it out from the probability. You can still subtract out the 0 from the probability, or you can just skip it. Okay, so it's kind of not necessary. So here's an example. John is going to buy a car. He has driven 2 cars today, car A and car B, but will only purchase 1 car. So the probability to purchase car A is 0.42. The probability to purchase car B is 0.28. What is probability he purchases car A or car B? So if I was to do this, I would say the probability of car A or B equals the probability of buying car A plus probability of buying car B minus probability of buying car A and car B. So he said there's a 0.42 probability he buys car A, 0.28 probability he buys car B. And then really, this would kind of be minus 0 because he said he's not going to buy 2 cars. He's only going to buy 1 car. So when you realize that there's no that there's no overlap, when you realize that these are mutually exclusive events, do you even have to write down that minus 0 there? No, not really. Okay, so I'm just kind of showing it there to emphasize here that it's not necessary. So this would be a 70% probability that he buys either car A or car B, even though there's a 0% chance that he will buy both of them. Okay, so I want to give you guys a chance to fill out this chart. And so decide whether the following events are mutually exclusive or not. Hint, they are mutually exclusive if they cannot both be true at the same time. So they are mutually exclusive if they cannot both be true at the same time. So I'm going to say flip a coin, heads or tails. Those are mutually exclusive because it can't be heads and tails, correct? Okay. So the second one, pick a card, then flip a coin. I should have expanded on this. So let's say that you pick a card, and let's say you want to get king, all right? And then flip a coin and you want to get heads. So are those mutually exclusive or not? I would say these ones are not mutually exclusive because it is possible you could get heads and get a king, right? Because those could both happen at the same time. All right, jury verdict, be guilty or not guilty. Can those both happen at the same time? I would say no, and so that means they are mutually exclusive. Pass math class and pass science class, can those both happen at the same time? Yes, they can, so those are not mutually exclusive. And then temperature, freezing or boiling, can those happen at the same time? No, you can either be freezing or boiling. You can't be freezing and boiling. You could pass math class or science class, but you could also pass both of them. You could pass math class and science class, all right? All right, cool. Okay, so I actually don't, or actually let me stop my recording here. All right, cool.